In this third example, our first equation is 6x minus 2y equals 10. The second equation is x plus 6y equals negative 11. Now what's different than the previous example is that none of the variables are isolated. None of them are by itself. But let's take a closer look. Mainly in the second equation, and again, just because I said second equation doesn't mean it's always going to be the second equation. It's just, let's take a look at the second equation, and here's why. Notice how the x, you have a variable x that is by itself, meaning an invisible one for the coefficient. So if that happens, then we can use the second equation to get x by itself. Now if the first equation has a variable by itself, then do that. But in this example, our second equation, we have an x by itself. So that means I'm going to subtract 6y on both sides, and I'm going to have x equals negative 11 minus 6y. Again, the order doesn't matter. You could have written as x equals negative 6y minus 11. So now we're going to plug in the second equation into the first, mainly into where x is. So we're going to have, and I'm going to write over here, 6, and instead of x, I'm going to write, say I want to use the second one, negative 6y minus 11. And then keep the minus 2y equal to 10. So again, I'm using the first equation where the second equation is plugged into x. Everything stays the same. 6 minus 2y equals 10. The only thing different is I swapped out the x with the second equation. This is 0 minus 6, so it's going to be negative 36y minus 66, and then minus 2y equal to 10. Combine my y's together, so that would be negative 38y minus 66 equals to 10. After that, I'm going to cancel out my negative 66, so I'm going to add 66 on both sides. So I'm going to have negative 38y equal to 76. After that, to solve for y, I'm going to divide both sides by negative 38. So that's going to have y equals to negative 2. Alright, so y equals negative 2. So again, you can use any of the original equation to solve for x. So say I want to use the second equation because the x is by itself, meaning an invisible one in the coefficient. So I'm going to write the work here, x plus 6y equals to negative 11. So I'm going to plug in negative 2, so it's going to be x plus 6 times negative 2 equal to negative 11. So I'm going to have x, negative 2 times 6, that's going to be minus 12 equal to negative 11. I'm going to solve for x, so I'm going to add 12 to both sides. So it's going to be x equal to positive 1. So I'm going to write here x equal to positive 1, because negative 11 plus 12 is just 1. And then if you want to check your answer, simply plug it into both equations and see if it works. So here we start off where both equations, where neither of them had a variable isolated, but if we had take a closer look, we see that in the second equation, the x has an invisible 1 coefficient, so we can get x by itself. And the same process can be applied if you're trying to get y by itself. So it's going to be the same process when you get the variable by itself, do substitution, And again, make sure you solve for x and y. You should have two answers.